Okay, welcome back, guys. Here we are from June 18th paper with us. Okay, so here are my annotations with me. So this is the first question on binomial theorem. You can also call this binomial expansion. Okay, so it says the coefficient of x squared and the expansion of the sum of these two binomials is 330. So we have to find the value of the constant a. This is these are very easier kinds of binomials here because you just have x here. There is no power on x and there is no product going on. So it is up to you. You can write the first three terms up to x squared, or you can directly write the term which can have x squared in it. So I'll be writing directly this as 6c 2. Yes, 6c2. This is 2 raised to power 4, and this is x over 2 squared. So I should mention here that I'm writing the terms in x squared so that, Mariam, I don't have to put those dots here, okay? So the terms in x squared are, so this one is going to be 5c2, and this is a cube and x squared. Guys, this in this P1 binomial distribution, this is much different. In fact, opposite to your S1's binomial. There you have the formula NCR, and this P has the power R on it, okay? And this Q has the power N minus R. So don't mix them up, okay? So 6C2, I think it is 15, Hannah. 15 into 16 into x square over 4 plus 10 a cube x square, and that is equal to 330 x square. So we can say that 60 plus 10 a cube is equal to 330. So this 10 a cube is equal to 270, and your a cube is 27. Therefore, your a is going to be 3. That is the answer to the first part here, okay? So let's go to the next question number 2. Okay, second question. Now this looks to be from the quadratics, I think. The equation of a curve is y equal to this. Find the set of values of k for which the whole of the curve lies above the x-axis. It lies above the x-axis. Now, the first thing I should note down here that the coefficient of x square is positive. That means the curve is going to be a happy face curve. It is going to be a curve like this. Okay. Now, if it has to be above the x-axis, that means this equation is not going to have any connection with the x-axis over here. So that means there are no real roots for this equation. So for that purpose, you will have to like recall that you will have to put this b square minus 4ac less than 0 here, okay? So that is going to be 36 minus 4k is less than 0 is negative, minus 4k is less than minus 36. Let's divide both the sides by minus 4, so this is going to be k is more than 36. Oh, sorry, this is 9. You see, that is why I always tell that I can never get top in the word because I make these silly mistakes. So this is k is greater than 9. That is the first part. Then we go on to the next part. It says find the value of k for which the line, this is a tangent to the curve. Okay, I'll have to write that equation on the side here so that let me write that equation here. This equation is y is equal to x squared minus 6x plus k. I think he has set the whole question on the concept of this discriminant over here. Anna, um, so okay. So the second part. The curve has the equation y is equal to x squared minus 6x plus k. Line has the equation y equal to 7 minus 2x. If you had to find the points of intersection, and like suppose there was a number instead of this k, you had to solve these two equations simultaneously. And now there's a condition that this line is a tangent. So you will be starting this like we start when we solve them simultaneously, okay? So we'll be equating them x squared minus 6x plus k, that is 7 minus 2x. This is x squared minus 4x plus k minus 7 equal to 0. So if this line is a tangent to this curve over here, so this means this quadratic equation should have how many solutions? One. So that means you will be putting the discriminant equal to 0. Okay, b square minus 4 is equal to 0. So this is going to be 16 minus 4 into k minus 7, that is equal to 0. We divide the whole equation by 4. This is 4 minus k minus 7 equal to 0. K minus 7 is equal to 4 and k is going to be equal to 11. So this is the value of k for which this line is a tangent to the curve. Okay, we are on to the third question. Okay. So you guys please give a try to this question and then I'll be solving this. Okay, third question, a company producing salt from seawater changed to a new process. The amount of salt obtained each week increased by 2% of the amount obtained in the preceding week. So is that AP or GP? GP of the preceding week, okay? So we can right away write down that R is going to be 1.02 because it will always be 102% of the preceding year. Given that in the first week, they got 8,000 kg of salt. Okay. Find the amount of salt obtained in the 12th week. Okay, so we have to find A12. So that is AR raised to power 11. That is 8,000 times 1.02 raised to power 11. Can someone please use the calculator and tell me how much is this? 9,947 kg. And you should mention this 9,950 kg. Correct to, बेशक लिख दें यहाँ पे, correct to 3 significant figures. ठीक है? Because इसका एक mark can be deducted. Okay, we move on to the second part. Find the total amount of salt obtained in the first 12 weeks. So what do we have to find now? Sum of 12. Good. So guys, yeah, this would be the second part here. We have to find S12. So your R is more than 1. So I'll be writing it as A into R raised to power 12 minus 1 over R minus 1. So this is, change color a bit. This is 8,000 into 1.02 raised to power 11 minus 1 over, please use the calculator and tell me what do you get. This should be a big value. Yes. This is 97,350. So we can write it as, I think this is exact. So just to be on the safer side, this is 97,400 kg, correct to 3 significant. Yes, beta. This has to be 12. That was 11 over here because when you have to find the 12th term, so this is, the formula is basically AN is going to be AR raised to power n minus 1. So please, you need to do the corrections here. This is 12 here. And 97,000? Okay. Let me clear this. So this is 107,000. That's it. Correct to three significant figures, है ना? So that is it. So that's my mistake. It has to be 12. I wrote 12 correctly here, but I just wrote this 11 here. So you see how careless I am. Okay, let's move to the next question. This is, yes, beta. The last question, beta. The last question. Okay, the function f is such that, let me complete this. Is there any problem with the previous question, beta? Okay, fourth question. The function f is this. It is given that f of this is this and f of this is this. Find the values. Okay. So f of x is a plus b cos x. F of pi by 3 is 5. And we know that cos pi by 3 is half, है ना? So this is 5. So this gives us a plus b by 2, that is equal to 5. That is the first equation. Okay? And then it says f of pi is 11. So this would give you a minus b, that is equal to 11. So you just solve them simultaneously. I think we should subtract them. So we'll have 3 by 2b, that is equal to minus 6. And your b is going to be minus 4. And you put that into the second equation. Your a is 7. Please check if a is 7 and b is minus 4. Yes, Aisha, please check the answer, beta. Okay. It says find the set of values of k for which this equation has no solution. Okay. So the equation is, let me write down the equation here. This is 7 minus 4 cos x equal to k. Okay. And let me clear the rest. It has no solutions. Okay. I think someone asked me this question recently. Okay. So when there is no solution, so let me just write it as 4 cos x is going to be 7 minus k. And cos x is going to be 7 minus k over 4. Guys, if you have, for example, cos x equal to a. So remember, your cos x is always between what two limits? This is 1, 0, minus 1, and this is going to be 0 here. So cos x is always between 1 and minus 1 if you want to have the solution of it. Okay? So if there is no solution, then this means either 7 minus k over 4 is less than minus 1, or the 7 minus k over 4 is greater than 1. Because we have to give those values of k where there is no solution. So the solution is there if you are within minus 1 and 1. So now we will put that beyond minus 1 and 1. So please solve that. This will give you 7 minus k is less than minus 4. This will give you minus k is less than minus 11. This is k is greater than 11 from here. And this is 7 minus k is more than 4. Minus k is more than minus 3. And k is less than 3. So these are the limits, less than 3 and more than 11. Okay, so I just put an or between them. Okay, so that's it, guys, from this session. See you in the next session with the remaining questions of this 2018 June's paper. Alright, guys, we're going to resume this June 18's paper 12, which is in fact paper 1. And let me show you, I have skipped one question from here, guys. This question was basically on vectors. Now the vectors are no more in your P1. So when I'll be doing the P3 paper, then inshallah we'll be doing this question. So moving on to the question number 6, then you can see this question looks to be on the circular layer. Okay, so it says the diagram shows points A and B on a circle with center O and radius R, the tangents to the circle. So the moment I read this tangents word, I should immediately show this a right angle over here, okay? And the tangents on the circle, they are equal. So the shaded region is bounded by the minor arc AB and this, and the angle is 2 theta. In the case where the area of the sector AOB is the same as the area of the shaded region, the sector AOB, in the case when the area of the sector AOB is the same as the area of the shaded region, show that tan theta is 2 theta. Okay, so area of the sectors formula, we have area is equal to half r square theta, or this is half rs, and the shaded area would be the area of the whole this quadrilateral minus this. Okay, so for that I'll have to divide this into two parts, people. Let me draw a line from here to this. Okay, now I can easily find the area of the triangle, and then I can double it to determine the area of the whole of this kite shape. Actually, this is going to be theta over here. Okay, it says in the case of the area of the sector AOB, area of the sector AOB, that is going to be half into r square into 2 theta is the same as the area of the shaded region. So the area of the shaded region is going to be, look, I have to bring in this tan theta into it. So I will intentionally be writing this in terms of sine or cos, okay? So the area of this, for the area of the kite, I need to write, can I write this as r tan theta over here? Kyun bhai? This should be, I should be allowed to write this as r tan theta because it's a right angle triangle. So this tan theta is going to be, suppose this side is x. So this is x over r. So your, oh, this is r, yeah, I have written this correctly. This is r tan theta. So the area of the whole shape is twice half into base into the height. Yes, guys? So this OB is the base and this BT is the height. Okay, so I multiplied this by 2 because there are two triangles making up this whole quadrilateral. So this is going to be r square theta, and this 2 is cancelled by 2. This is going to be r square tan theta. So we have here tan theta is going to be, where did I go wrong, guys? This is half r square theta. Oh, I didn't write. Minus this half r square 2 theta. Because we only have to put that equal to the shaded part, okay? So for that, the total area minus this sector. So r square theta is equal to r square tan theta minus r square theta. So you have 2r square theta is equal to r square tan theta. So this gives you 2 theta equal to tan theta. Yes, guys? Anna? Okay, so let's see what's there in the second part. It's in the case where R is 8, okay, and the length of the minor arc is 19.2. Find the area of the shaded region. Okay, let me clear all of this. Okay. Now it has given us R equal to 8, R equal to 8, and minor arc AB, that is 19.2. So we have to find the shaded region. Okay, let me go back to this so that I can use all this information here. Okay, so this R is 8 now. This R is 8, okay, and the minor arc is 19.2, okay, fine. Then we have to find the area of the shaded part. So area of the shaded part is going to be, okay, let's find this theta first of all. Can I say that 19.2 is equal to r theta, that is 8 into 2 theta. So your theta is 19.2 over 16. Can please someone use the calculator and tell me what is this value? So this is 1.2. Now theta is 1.2. We have already seen that this side was r tan theta in the previous part. So this is going to be 8 tan theta, that is 8 tan 1.2. So we have to find the shaded parts area. So let's do that. Theta is already with us. This should be 0.6 here. I'm making a mistake here. This is tan 0.6 because 2 theta is no, this is theta, Anna. So I was writing this correctly. Yeah, this is 1.2. No problem. This is 1.2 over here. Okay, so where to find the area of the shaded region? So that is going to be the total area of this kite minus area of the sector. Can I write it like this? The shaded area is equal to twice half into 8 into 8 tan. Now please keep your calculator in radians mode and tell me what do you get. Minus area's formula is also half RS. So I'll be finding this area of the sector as minus half into 8 into 19.2. Please use your calculators and tell me what do you get from this. This is 64 tan 1.2 minus 4 into 9. Yes, beta, what do you get? 37.87.8. And the unit is, what is the unit here? I'm just writing unit square. I think that was centimeters. So that is how you find the shaded area. So here is the question number 7. You must start solving it and then I'll be following you people. It's a question on completing the square. So this is 7. I need to take a minus 2 common from here. X square plus 6x. So I'll be writing a plus 3 square and a minus 3 square to complete the square. 7 minus 2 into x plus 3 whole square. We need to throw this minus 9 out. So minus 2 into minus 9 will be plus 18. So this is 25 minus 2 into x plus 3 whole square. Okay, so this is going to be a negative curve, and this point over here is going to be minus 3 comma 25. Okay. Going to the B part, it says show that the coordinate of the stationary point. State the coordinates. We have already stated the coordinates are minus 3 comma 25. What's in the third part? The function g is this for x is more than, but the same function has been named as g of x. State the smallest value of k for which g has an inverse. When can we have an inverse, Bacho? When your function is 1 to 1. So that means there should not be any turning point in your function. So either you consider the curve after this minus 3, x equal to minus 3, or before minus 3. Since you are going to go towards the positive side, so the minimum value of k is going to be minus 3. So for minimum k equal to minus 3, this function is a one-to-one function and we can write its inverse. Okay. It says for this value k, find g inverse of x. No problem. We will be putting that equal to y. Let me use this completed square form here. So 25 minus 2 into x plus 3 whole square equal to y, and you will try to make x the subject. So 2 into x plus 3 whole square is equal to 25 minus y. X plus 3 whole square is equal to 25 minus y over 2. So you have x plus 3 equal to the square root of 25 minus y over 2, and this plus 3 goes here, this is going to be minus 3. Now one thing, when you take the square root, if the domain given is towards the positive side as we have here, you keep a plus with the square root. And if for instance the domain was pointing towards the negative side, then you could have a minus with the square root. Now, therefore, the g inverse of x is going to be the square root of 25 minus x over 2 minus 3. That is its inverse. Okay, and from this we move on to the 8th question. Okay, this says points A and B have coordinates this and this. The equation of the perpendicular bisector is this. Oh, find the values of the constants h and k. Now suppose here is your point A, which is h comma h. Okay, and here is a point B, which is 4h plus 6 comma 5h, and this is your perpendicular bisector going like this. This is the perpendicular bisector, and you have its equation, which is going to be this is 3 plus 3x plus 2y equal to k. There is a right angle, this side is equal to this. Let me assume that this point is M. So first of all, you have this M. You can find this M in terms of h. So that would be h plus 4h plus 6 over 2, comma, h plus 5h over 2. That is your point M. This is going to be 5h plus 6 over 2, comma 3h. Okay, this is one thing. Secondly, you can find the gradient over here, the gradient of AB, which is going to be 5h minus h over 4h plus 6 minus h. This is 4h over 3h plus 6. Other guys, if this is the gradient of AB, can I say this 4h over 3h plus 6 And I just write this equation here. Um, if you look at this one, um, this is 3x plus 2y equal to k. That is the equation of the tangent. So 2y equal to minus 3x plus k. I'm writing this in the slope intercept form so that I can see what is its gradient. So the gradient of the tangent is minus 3 over 2. What will be the gradient of the line AB? 2 over 3. Very good. So I'll be putting that equal to 2 over 3 over here. Okay. Let's solve this. This will give us the value of h. So this is 12h. That is equal to 6h 6h plus 12. So we have 6h equal to 12 and your h is equal to 2. Okay. So h is 2. So once your h is 2, we have got one value. Now let's put the value of h into this point m. What is this point m now? 10 plus 6, 16 over 2 is going to be 8, comma 6. So if you put this point m onto this, into this equation of the tangent, you will be getting the value of k. Let's do that quickly. So this would be 3 8s are 24 and 2 6s are 12. That is equal to k. So your k is going to be equal to 36. Oh, it was a very big, long question. Okay, now let's see what is there in question number 9. Here is the question number 9. Okay, your favorite calculus is here. Okay, a curve is such that dy by dx is this. Okay, find the equation of the curve. Now you have to be very careful. It's asking for the equation of the curve. Some of you start finding the equation of the tangent here. It's asking for the equation of the curve. Okay, so you have this. So this becomes a question on differential equations. This is a kind of differential equation here. The point is 2 comma 5. So this is dy. So let's integrate both the sides with respect. This is with respect to y. This is with respect to x. So we have y is equal to 4x plus 1 raised to power 3 by 2 over 3 by 2 times 4 plus c. Never ever forget to write this plus c over here. Okay, so let's put this point into this equation here. This is 5 is equal to 9 raised to power 3 by 2 over 6 plus c. So we have 5 minus, this is 27 over 6. What is 27 over 6? 1.5? No. 27 over 6 is going to be 3 9s. This is 4.5, yeah. So your C is going to be half. Therefore, the equation of the curve is going to be 1 over 6 4x plus 1 raised to power 3 by 2 plus half. That is the equation, the required equation of the curve. Okay. Any question, Mitchell? Okay. We move to the second part now. I'm writing this equation on the side so that remains visible to me. Let me see what is there in the second part. A point P moves. Okay, so for this purpose, I need to have, what was that dy by dx given to us? The square root of 4x plus 1. And what was that point P? 2 comma 5. Okay. So it says a point P moving along the curve is such that the y coordinate is increasing at a constant rate. So he's giving us dy by dt. That is 0.06. Find the rate of change of x is asking for dx by dt. So you see, you will have to use the chain rule over here. Before you do that, you need to have the numerical value of this dy by dx. So let's put this 2 into this square root of 4x plus 1. So this is going to be square root of 9. That is equal to 3. Some of you people are really confused over here with the square root of 9. This was already there in this equation. So you don't need to write a plus minus with this, okay? You write a plus minus when you are yourself introducing the square root. So now we need to have this dx by dt. So that is going to be dx by dt. So you have dy here, you have dy here. So the reciprocal of this is 1 over 3 times dy by dt, that was 0.06. So this is 0.02. That is your rate of change of x. Okay. So from this we move to the next part. It says show that the d2y by dx square over dy by dx is a constant. No problem. Let's try to show that. Okay. So let's do that. But so for this, we need to have the d2y by dx squared. So if you differentiate this once again, which is already differentiated, you will get the second derivative. So this is 1 over 2 under root 4x plus 1 times 4 over here. Okay, so this is 2 over under root 4x plus 1. Now let's multiply them together. So d2y by dx squared times dy by dx. So this is 2 over under root 4x plus 1 times under root 4x plus 1. Cancelled out. So yes, this is, so we have proved that this is a constant. Okay, question number 10. A typical question on trigonometry. How can you solve this equation, bacho? 2 cos x plus 3 sin x equal to 0. Yeah, you will divide both the sides by cos x here, okay? So you will start dividing both the sides by cos x. So you have 2 plus 3 tan x, that is equal to 0. So this 3 tan x equal to minus 2. Your tan x is going to be minus 2 by 3. Okay? Your tan is negative in these two quadrants. So someone please, keeping your calculators mode in degrees, tell me what is tan inverse of 2 over 3. Don't find the tan inverse of minus 2 over 3. I will be writing it as minus 2 over 3, but you will find tan inverse of 2 over 3. And tell me correct to one decimal place. Yes. Tan inverse of 2 over 3. 33.6. Okay. This is 33.6. This is 33.6. So your x is going to be, first of all, this one. What is 180 minus 33.6? 146 point, sorry, 4. Is that 3 or 4? Okay, so the rounding off, okay. And this one is going to be 326 point. You are saying 3 here and 4 here. Challenge. So they are saying 3, and so I'll keeping it like this. Okay. So this is 326.4 degrees here. Okay. So this part is solved. Let's see what is there in the next part. It's a sketch on the same diagram. Okay, your favorite sketching is here. Sketch on the same diagram the graph of y is equal to 2 cos x and y is equal to minus 3 sin x. Okay, I'll be drawing y equal to 2 cos x here, and I'll draw that in red. First of all, you see that for the sketches of sine and cos, we keep the intervals of 90 degrees, okay? So I'll be keeping the 0, 90, 180. Try to keep a reasonable scale here, okay? And this is 2 cos x, so here it is 2 and here it is minus 2. I need to have 3 here as well for the second graph because it is minus 3 sin x, okay? So, you know, the cos x is like, if you want to sketch y is equal to cos x kind of a graph. So this starts from the maximum, goes down to the axis, then down towards the minimum, then axis, then maximum, and so on. So we'll be doing the same here. Since this is your 2 cos x, the maximum, like, you know, it is going to be between 0. So cos 0 is going to be 2. This is 0. This is minus 2. And this one is going to be 0. So this is maximum, axis, minimum, axis, and here is the maximum. So that is how you will have the graph for this y is equal to 2 cos x. And now for the graph of, let me keep this in blue, y equal to minus 3 sine x. Now this y is equal to minus 3 sine x for this graph, okay? Normally you start from the axis. You go up to the maximum, then you come down to the axis, then minimum, then axis, and so on. But see, there is a minus sign over here. So from axis towards the maximum, the flow would be axis, minimum, axis. Like, you know, the flow would be opposite over here. So I am here at, and again for the sine, this is going to be, sine is 1 here, sine 0 is 0. So this is going to be 0. Here it is going to be 3. And because of minus 3 sine x, you will have minus 3 here, okay? And you normally have minus here, but it would have 3 over here, okay? So from axis, let me draw this in blue. So axis, minimum, axis, maximum, and here is the axis. So you will have the sketch of this like this. So that is the graph of y is equal to minus 3 sine x. Next, it says use your answer to part 1 and 2 to find the set of values of x for which this is positive. Like this is positive, okay? So you see that 2 cos x plus 3 sine x. One of the equation is y equal to 2 cos x, okay? The other equation is y equal to minus 3x, minus 3 sine x. So when you start solving them simultaneously, you will equate them. So this would be 2 cos x equal to minus 3 sine x. So this is 2 cos x plus 3 sine x. When you equate them, so you see you have two solutions here. One solution is over here and the second solution is over here. So for instance, if he was asking you for the number of solutions of this equation, your answer could be positive, okay? Now to answer this question, you see, it says 2 cos x plus 3 sin x is more than 0. So since we have to use these answers as well, where we had found that this point over here is, that is 146.3 degrees, okay? And this point over here is, at this, the angle is 326.4 degrees. Now it says for which this is positive. Can I write it like this, that this 2 cos x is greater than minus 3 sine x? Okay, so for this, you see, we have to see what are the values of x for which the red part of the curve is above the blue part, because the red one is representing your cos x. Okay, so the answer to this last part is, it is either x, oh, let me write it here, the third part's answer, I'm writing it here, it is x is between this 0 and 146.3, or x is going to be between 326.4 and less than or equal to 360 degrees. That is the answer to this third part. Okay, the question number 11. It's the diagram shows part of the curve this, the line y equal to 4, and the point P and Q. Okay, show that the tangent of the curve at P and Q meet at point on the line y equal to x. Oh, okay. So what would that mean to you, that the tangents on the curve at P and Q, they meet at the line y equal to x? How would you show that? What is special about the points of the line y equal to x? The x and y coordinates are same. So basically you will be finding the equations of tangent at both the points. You will solve them simultaneously, and you will see that they will have the x and the y coordinates same. So that is what we have to prove here. So please start solving this. Okay, so if we have to do that, we need to differentiate this. Okay, let's differentiate this first of all. So I'll be finding dy by dx. The derivative of x by 2 is half, and this 6 over x should be assumed as 6x is per minus 1. So this will be minus 6 over x squared. Okay, we can determine the points P and Q. If you put your y equal to 4, let's do that. X over 2 plus 6 over x, that is equal to 4. So this 2x, this is x squared plus 12 equal to 4, x squared plus 12 equal to 8x, x squared minus 8x plus 12 equal to 0, and this is x minus 2 into x minus 6 equal to 0, x equal to 2, and x equal to 6. That means this point P is 2, 4, and this point Q is 6, 4. So we have got the dy by dx. So m at P, that would be, we'll put x as 2, 1 over 2 minus 6 over 4. That is 1 over 2 minus 3 over 2. Is that minus 1? Yes? Okay. So the equation of the tangent. Equation of the tangent at P. That is y minus 4 equal to minus 1 into x minus 2. Y is equal to minus x plus 2 plus 6. That is the equation number 1. Okay. Next, we need to write the equation of the tangent at this Q. So we'll find the gradient. We'll be finding the gradient. Come on, yeah. The gradient at Q. So that is going to be half minus 6 over 36. What is that? This is 3 minus 1, 2 over 6, that is 1 over 3. Anna? Yeah, therefore the equation of the tangent That is y minus 4 equal to 1 over 3 into x minus 6. So this gives us 3y minus 12 equal to x minus 6. So this is 3y equal to x plus 6. That is our equation number 2. Let us solve them simultaneously. I'll be writing the other equation under this and I'll be adding them together. This is y equal to minus x plus 6. So this gives me 4y equal to 12. So your y equal to 3. Let's put that into any of these equations. Maybe in this equation, equation number 1. So you have y equal to which is 3 in fact. So this is 3 equal to minus 3 minus x plus 6. So your x is also 3. So this shows that both of these two tangents, if I could draw these two tangents, you will see that they are going to meet at the line y equal to x. So this point over here is 3 comma 3. This is 3 comma 3. So we have shown that they both meet at the line y equal to x. Now there's the second part. Find showing all necessary working the volume obtained when the shaded region is rotated. Okay, we have to give the answer correct to in terms of pi. So the volume about the x-axis. Okay. So if I draw the lines here, guys, so if I shade, all the area under the line 1 and I rotate this, what kind of solid I'll be getting? Cylinder. I'll be getting cylinder. So the volume of cylinder, like this would look like this if I just take it down here, like you see, this would be a cylinder like this if we rotate this around the x-axis. Okay? And here is this, all of this is excavated from this. So, a very weird kind of a hollow kind of cylinder you will get, whose borders cross section is like this. Okay, so we have to find the volume of cylinder minus the volume under this curve. Minus the volume under this curve. Okay, let's do that. This is not difficult. This is tedious, It's a term that means there is a lot of working. It is not difficult at all, but there is a lot of working for this. Okay, so how do you find the volume of the cylinder? This pi r square h. This is pi. The radius would be, this is 4 is the radius here, okay? This is 4 square. And height is this. What was this x coordinate? That was 2. And this was 6. Yes? So the height of the cylinder is 4 into 4. So this is going to be 64 pi. Now let's find the volume generated by rotating this from these limits 2 to 6. Okay? So the formula is volume is going to be pi limit from a to b. Never forget to write this y square. Okay? So let's find the y square first of all. I'm going to find the y square on this side. So y square is going to be x over 2 plus 6 over x whole square. This is x square over 4. 2 into this, x's will be cancelled, so 6 will be left. And plus 36 over x square. So the volume of this shaded part would be pi limit from 2 to 6. This is x square over 4 plus 6, and I will be writing this as 36x raised to power minus 2 so that I can integrate this. So this is pi limit from 2 to 6. Um, so this is going to be just a bit simplifying here, plus 6 plus 36 over x square. Well, let's put the limits here. So I'm going to write it here. Finally the volume is going to be 64 pi, the volume of the cylinder, minus this. When you put your x as 6 here, this is going to be pi into 36 over 4 is 9 plus 6. 36 over 36 is 1. When you put 2 here, 4 over 4 is 1 plus 6, and this is going to be 9. Okay? I had to put. Uh, I haven't integrated this. Oh, let me integrate this. You see, this happens in these long questions. I have to put the integration sign here. Okay, so this will be, let me integrate this first. I need to cover this. Okay, this color maybe. You see, I was getting 0. I got confused. Okay, what is happening? So this is x cube over 12. Okay. This is 6x. And this is minus 36 over x. That is we get after the integration. Now we have to put the limits here. So this is pi into beta 6 cube over 12 is, dekhna, 6 cube over 12, 18, plus 6 into 6, and minus 36 over, this is minus 6. And then you have minus x cube, that is 8 over 12, that is 2 by 3, plus 12 and minus 18. Can you please simplify all of this and tell me what do we have in terms of pi here? So this is the answer to this question, 10 volt over 3 pi unit cube. That is the volume that you will be getting. Okay? Do we have any other question here? Yeah, that's the end of the paper. Inshallah, next we'll be solving a P4 tomorrow, inshallah.